Okay, in this problem, we're going to use linearity and the assumption that I0 equals 1 milliamp to compute the current I0 in the circuit if I is equal to 6. By linearity, there's a constant proportionality between the current I and I0. So what we'll do is we'll assume that I0 is equal to 1 milliamp, work back through the circuit, calculate I, and then we'll essentially know that constant proportionality. So to start, here's our circuit. We're going to start off with I0 is equal to 1 milliamp, and what we're going to do is we're going to work back toward I. So by Ohm's law, this voltage is 3 volts, and that's the same as the voltage across this resistor. So by Ohm's law, then we know that the current flowing through that resistor is 0.5 milliamps. Now we can use Kirchhoff's current law. We can find this current. Let's call it I1. So by Kirchhoff's current law, I1 then is equal to 0.5 milliamps plus 1 milliamp, or 1.5 milliamps. And now the voltage across this resistor by Ohm's law then is 3 volts with that polarity. Now we can calculate this voltage Vx, and we can do that by using Kirchhoff's voltage law around this loop. So Vx is equal to 3 plus 3 equal to 6 volts. So now that allows us to calculate this current I'll call Ix, because now we know the voltage across those two resistors in series. So Ix is 6 divided by 12 kiloohms, which is 0.5 milliamps. And now, if we apply Kirchhoff's current law at this node, okay, the current I then is 1.5 milliamps plus 0.5 milliamps, which is 2 milliamps. So if we notice then that when this current is 1 milliamp, this current is 2, so this tells us there's a constant proportionality. Basically, I0 is 1/2 I. So if we go back to our circuit and we say, well, if I0 equals 1 milliamp, then I is equal to 2. So then it follows, if I is equal to 6 milliamps, then I0 is equal to 3 milliamps.